Hey guys, welcome to Unit 10, Lesson 2. Our topic today is extreme values. So let's get started with the warm-up. It says a graph of f of x equals x cubed plus 4x squared minus 3x minus 5 is given. On what interval or intervals is f of x increasing or decreasing? So anytime we read graphs, we always read graphs from left to right? So let's say if you were to read this graph, you're going to be reading it in this order. So from left, you're going to start here. So think about it. If you were walking up a hill, so what's happening? If a person was to take this path and going up and down this hill or this path, what's happening? So from this point, if there's a person, he is going up here. So what's happening here? It is increasing till this point. From this point onwards till this point, he's going down, so the slope is decreasing. And then from this point onwards till here, I'm going to actually put arrows. There are arrows in the end. It is increasing again. So on what intervals is f of x increasing? So let's write down our increasing intervals. It is from negative infinity to negative 3, and from it's like 0.5 to positive infinity. It's decreasing over the interval negative 3 to 0.5. So now it's asking us, does f of x has a minimum or maximum point? If so, what are they? So minimum and maximum. So minimum and maximum has to do with wherever you have your slope or your first derivative equal to 0. So those are two places. And if you look at your slope is going from positive to negative. So when it goes from positive to negative, you have a max. So your max is at negative 3, 13. And you have a min at, it's going from what? Negative to positive, your slope. So it is at 0.5, negative 5. It's more like negative 6 actually. Okay. So now what do you notice about the derivative at the min and max points? Describe the behavior of the derivative around these points. I kind of said a little about it. Derivative has to do with your slope of the tangent line, right? So if you look at it, the slope of these tangent lines is what? 0. Your first derivative f of is 0 here, and same thing here. So what can I say? My first derivative will be always 0 at your max and min, and when it changes from positive to negative, when your first derivative changes from positive to negative, you have a max. And when your first derivative changes from negative to positive, you will have a min, which we kind of saw it up here. And we're going to explore these topics more, but I just wanted to talk about in terms of the derivative. So kind of you start looking for it and start understanding these concepts. Without seeing the graph, how could we determine where the minimum or maximum points are? So here we would have done what? Set my derivative equal to 0, and then we would have found the horizontal tangent lines, and that would help us determine the mins or max points. Without seeing the graph, how could we determine which of these 2 points is the maximum and which is the minimum? So basically, I could have done that by sketching a number line and knowing what's happening, right? Looking at my critical values and going from, my graph is going from positive to negative to positive, right? So what's happening when it's going from positive to negative? You look from when the slope is changing from positive to negative. So since it's changing from positive to negative, you will have a max here. It's changing from negative to positive, you'll have a min. So you have a max, and here you will have a min. Okay, so this is how you could have determined without even sketching the graph, and we'll explore these topics more, but I just want to give you an idea using your first derivative, using your number line, how can you determine your maxes and mins. Okay, so copy these into your notes, please. So it says an extreme value is any max or min value. Be very careful about that. Those are your extreme values. And what's a critical value of a function? F is a value x equals c in the domain of f such that either your derivative is equal to 0. When your derivative is equal to 0, early on in the year we talked about is when your numerator is equal to 0. And your derivative does not exist is when your denominator is equal to 0, and that usually happens when you have corners, cusp, or vertical tangent lines. Right? That's where your derivative does not exist. So let's mark up our critical values and extreme values. Remember, your extreme values have to do with your max and min, absolute max and min, and your critical values are your relative max and min. So here are the endpoints on the graph. So this is actually your absolute minimum because it is the lowest point on the graph. Now, how do we look for our critical values? Our critical values are wherever your slope is either does not exist or equal to 0. So here my slope of the tangent line is equal to 0. So that is my critical value. And that happens to be a relative max. And why is it a relative max? Because it is a high point in comparison to points around it, right? So here again, this is another critical value because my first derivative is equal to 0, and this happens to be your relative min, right? Because if you compare it to the points around it, it is a comparative low point. So now you have another critical value here, but the slope does not exist. So this is a critical value. Critical. Oh, spelled it wrong. Critical value. And the slope does not exist here, but it is an absolute max. Because this is the highest point on the graph. So let's talk about basically, so we can all say is that we had a total of 3 critical values here, 1 absolute max and 1 absolute min. Again, your absolute max and min can happen at endpoints, but your relative max and min will never happen at endpoints. Please note that. Okay, so the other words that can be used for absolute and relative are global and local. So I will be mostly using absolute and relative. It doesn't mean that you would not see global and local. Also, there is the same thing for absolute and relative. So absolute global extrema can only occur at a critical value or at an endpoint of an interval. A function f has a local relative max or max at c if f of c is greater than f of x. When x is near c, what does that mean? That it is a relative high point in comparison to the values around it. So you will have a max. A function f has a local relative min at c if f of c is less than f of x. When x is near c, same thing, it will have a relative low point in comparison to the other points around it. So something very important, local relative extrema can only occur at a critical value. And local relative extrema cannot occur at an endpoint of an interval. And it is for the reason that you can only have a relative high point or a low point if if you have things to compare around it, if you have values to compare around it. If there are no values to compare around, you cannot have a relative high or min. So that is the reason why it cannot happen at endpoints. So let's do the example one. So it says identify all the critical values of the graph below, then determine whether a local max, local min, or neither occurs at that critical value. So here a graph is given to us, and if you look at it, at f of a and at f of f, so this is basically my absolute min because it is the lowest point on the graph, right? But this cannot be an absolute max because this is not the highest point on the graph. So we cannot just, it's nothing as of now. So here we have, let's look for a critical values wherever the slope of the tangent line is equal to 0 or does not exist. So here you have your critical value. I'm just going to use CV for my critical value, and that's your relative max, right? So you have a relative max here. Again, why is it a relative max? Because my first derivative is equal to 0. Now you have another critical value here, but it happens to be your relative min, right? But the slope doesn't, the first derivative does not exist here, so it's a relative min. It is a critical value, so I'm just going to write it's a critical value and it is your relative min because it is relative low point in comparison to the other points around it. And then this, we have another critical value, and here it is also my absolute max, right? So for this lesson we are only going to be doing graphs, so I want you to skip example 2 and try numbers 1, 6, 7, and 9. So those are the ones that you're going to be doing for homework, so you can skip the rest. Good luck.